Okay, welcome back to PyraPOD. Yeah, this is our newest design for PyraTENT. So I like to quickly, I already made a video, but that video was based on a previous design, relatively crude, not showing much detail. But this one, we call it finished design. Yeah, basically it has everything. We have considered every detail, simplify, all the parts, and make it truly very easy to build. As you can see, this is a pipe-based structure using, for example, we suggest you can use PE pipes with steel inside reinforced, especially for the four columns. These four columns relative tall. Consisting topper portion and also underground portion, so buried underground, because we use this to build the a pond, a small pond in the center. The pond is filled with gravel and water, so you need to lay a pond liner underneath, and then you place the soap reservoirs and other containers in it, forming heat exchange region. That's critical because once you open the top, and then contain the heat, you need to store the heat so that the greenhouse or the tent won't be too hot during the day, and won't be too cold during the night, because at nighttime you fill the entire envelope, double layer cavity envelope with soap bubbles, to insulate. So the idea is to cool the whole structure using water during the summertime when it's too hot, and then at night and winter time you fill the double layer cavity with soap bubbles to insulate, to keep the heat inside. So that's the whole idea. As you can see, we separate the gutter. We call this gutter because it's really the function is it's just like gutter, to collect the soap liquid, and then and then pass it through. There's hole on each end, and the hole will drain the liquid back to bubble generator, and also bubble generator connect to the soap reservoir. So this way both the gutters and bubble generator are used as a way to capture the liquid and pass it through, right? Pass it back to the soap reservoir, right? The soap reservoir is located in the central, underneath the central platform. So that's what it is. In this design, we also separate the outer layer from the inner layer. Hopefully you can imagine as I describe. Basically we make the inner cover to be a skirt. See, between this line and this line, it's a skirt. Okay, the opening of the skirt is here, right here. We didn't show the line. In reality, almost you cannot, you won't see it. If we use zipper, like a white color zipper, you almost cannot see it. So anyway, so the opening is here. So, and then you first set up the frame, and then you then you install the gutters. The gutters hanging on these two horizontal bars, pipes, and then you connect to the bubble generator, and you can even test it, before you do anything else. You can test how it works, right? And then you wrap around, slip through the skirt between the arc and the tall column, and then close up at here, right? And then you hang, this is a mechanism, we call it the wings, right? So on the arc edge, on each of the arc edge corner, we have this mechanism, this just one layer fabric. There's a rope edge, actually two rope edges, there's a mechanism to just wrap around and then use zip tie to close the two rope edges. So this way, whole thing of the inner layer, right, got hang, and then tension to the arc. Yeah, that's how it is. It's hard to explain in words, but we're gonna have a simulation to show, how it works. But anyway, that's the situation. And then the top portion of the inner layer simply also use a mechanism to bind to the horizontal bars, like the shower curtain, then attached to the four horizontal pipes, right? And then it has a lap, has a edge, like a actual lap to go from the top, and place onto the top portion of the inner skirt. Okay, so this way the water can just flow over, and then the middle part is formed by 4 pieces of triangles, right, sewed together and then hang to the top using a bungee cord, right, to just create the tension, and that create a pyramid plenum, in this region. And then the last step is to just simply put on the exterior cover, as a hat, just hang onto the whole thing. Then the doorway, we made it this way because we use the air to insulate, because the air insulation property is not as good, so we need a deep doorway. The door open inside and the inner door open inside as well, so in order to for the two doors won't knocking each other, so we expand this depth, okay, make it really large, so you have a very good air insulation property. And then we have a fan. This fan is not for ventilation, really. It's mainly to create the little pressure in it. So the fan blow air in slowly to create some positive pressure inside. So it's kind of a airlock, because we need air to insulate, right? So that's what it is. And we have also a kind of a louver window, like in this shape, kind of so that even the inside is slightly pressured, air pressured. This way, when you enter into this building, right, you open the first door, and then the mosquitoes and others insect won't follow you. Then you enter and then you close the door. You open the inside door only after you close the door, so you got this cushion of air, right? So that's what it is. Once you have the inside temperature, humidity all under control, you don't need to ventilate. That means don't need to pass the inside air out, because the inside we use plant and some and even aquaponics, right, to regulate the balance between carbon dioxide and oxygen, right? Even this is meant for a tent, you can still do something. You can still, for example, have at least one region for growing. Have a aquaponic, the fish tank underneath, and then grow bed up above, right? Create a shelf, right? Then you can easily set up IAVS aquaponics. That's what we promote, because aquaponics growing will increase the thermal mass and also regulate the air inside. Even for living, this is okay. Anyway, so as you can see, we eliminate the second floor, so we don't need very strong supporting columns. Everything simplified, so it is really a tent. Okay. As I explained earlier, for those who don't know how the bubbles are produced and fill the entire cavity, I can simply just explain quickly. Note the door is facing east. Okay, so the left to the south and right to the north. So in this configuration, we allow these two bubble generator to work in pairs. That means they produce bubbles to fill the same space. Okay, so as you turn on this two, and then the bubbles will be produced, two streams of bubbles shooting out and fill this area first. You should imagine that it's the expansion of foam, right? It's the increasing of number of bubbles that fill this area. So as you can see, more bubble produced. The foam body will increase, getting bigger, until it fill this area, and then keep expanding, and then until it fill this side and this side, and then the bubbles got sucked into the bubble generator, and then bubbles crushed, right? And then the air create new bubbles. So that's how it is. If you turn on all 4 bubble generators at the same time, you're gonna have an entire fitting. In winter time, that's what you need, and also at nighttime you need to have a total fill in order to keep the heat you collected during the day inside. Okay, that's what it is. But in summertime, during the day, you probably just need to run these two bubble generators, because you need to fill the west, the southwest and east 3 sides for shading. Okay, to create a shading for your plant, right? That's when you need to do that. In winter time, during the day, you need to do the reverse. You need to fill the north side and the east and west, right? The 3 sides, so to increase the insulation property. Right? Whenever you have water, film, or wet soap bubbles, right, you start to capture the solar thermal energy, and that will help you to transfer the heat from the air to the soap liquid. So that's the whole idea. Hopefully you can understand. If you don't understand, then you may not know what I'm talking about. Okay, so yeah. Anyway, so this is for DIY project, but also we already asked our factory in China to start to develop this as a commercial product, so that everyone can buy. Yeah, if you don't know how to build one, then wait for we produce our own product, and then you can purchase and install. Okay, yeah, that's good. Hopefully it's clear. If it's not clear, make sure you ask questions. Okay, so that it help you to understand, and then if you're a handy person, you can build one right away. Yeah, so hopefully everyone can have this one. This is then you can say, hey, I have the best greenhouse, a new type of greenhouse that use soap bubbles to for shading for the summer, and for insulation for the night and winter. Yeah. Okay, see you next time.
Yeah, the horizontal ring at the top, it can be flat bar. It can be flat bar. I mean,
Yeah, this is flat bar as I've
yeah.
modeled it here. Yeah.
Mm-hmm.
I have to adjust where this angle is because it's slightly off.
Yeah. Yeah, flat. Yeah, that's it. So but it's like it's taking the load on the film right in the plane of the flat bar. It's using the edge of the flat bar against the direction of the film tension. Now, there's not a lot of tension. The other thing I was thinking of is we could do another bracing inner square of bracing into that top ring. So you know how you do a square in a square?
Sorry, you
Yeah.
want to
So
have another square inside this
yeah,
on the top?
from the center line of each of the ring square, top of the top of the inner skirt. Yeah,
You're talking
there.
about this one here, yeah?
Yeah, center line of that piece. Make an inner square going to the center line of the other ones. It could be a round tube. It could be more flat bar.
Yeah, I mean, I'll just sketch it up with some flat
Okay.
bar here.
Yeah. Okay.
And this is just a rough sketch. It's
Yeah. And if it's not needed, then we won't do it. It's like, do we need it?
yeah.
That's a question. But if we did need to keep this flat bar, from bowing, because we don't want it to bow. If it changes its shape, then it's going to not tension the skin.
Yeah.
Properly.
You know what I'm going to do? I'm going to just do one, and then I'll add it to that pattern there.
In fact, it could even be a cable, circle. A circle of cable that we tie it in there, and it creates.
If it's a cable, it's not going to give you that same reinforcing power. I really like the square and square, because then what you're doing.
I like tubing. I like tubing a lot.
Yeah. So this one here, if you look at it, what we've got then is this is a truss, and each corner then is a triangular truss that makes it very strong.
It means we've got like a what do you call it? A shear plate, right? We've got a rigid plate here now, doing it this way, because we don't have any surfaces except for the floor.
Mm-hmm.
And so you can get twisting. This will prevent twisting.
Right.
Mm-hmm. Yeah, torque in the system. So, and with this flat bar and with this sort of lightweight, it's possible that the building moves, a little bit, and I don't think that's a problem.
No. Well, I think that we can do some analysis and stuff, but I think because you've got it like everything's symmetric in the 4 dimensions, you got it tight on the top, you got it tight on the bottom. There might be some movement, but it should be relatively sturdy and it should spring back to its original shape.
That's it. Only it'll be a slight elastic movement, right? And it'll always spring back.
Yeah.
That's just the structure doing its work, right? Everything moves when you put a force on it. The only thing is usually, it's undetectable.
Yeah. Well, that's interesting. Let's see what's going on here.
Because of the slope of that,
Yeah. So we can make this instead of 1.5. Let's try maybe 1 inch.
Sure. It could be lighter. And it could be tubing, because then it would give that function of a compression load. So it could be a bracket, it could be a bracket, and we could have tubing with flat ends.
Yeah, I'll just do flat bar for now, and then we can change it later as necessary.
Oh, all right.
And don't worry about it sticking out here. We can trim that later.
Yeah. And there could be a little bracket that bolts, this, it could be, of course, everything has to bolt. We don't do any welding on the tent,
right,
on the tent system. And in the future, we're going to make some of these pieces, shorter, right, by some kind of splicing. In the future, this for now, this is kind of a prototype of the tent.
Yeah. So it would look something like this, right?
Yeah, I like it. That's basically it.
Yeah, and if we can do it vertical, like when you're talking about hanging stuff here.
Yeah.
The vertical, of course, is going to give you a little bit more strength. 1 inch might not be ideal, but depending on how much weight you want to hang, we certainly don't want to have 1,000 pounds.
No, not about, we're talking about like clothing.